Most Toyota owners are bleeding fuel economy without knowing it. Not because their engine is worn out, and not because they need a new hybrid battery, but because a handful of cheap, overlooked parts are silently dragging their mileage down every single day. We are talking about fixes that cost less than a fast food meal, yet dyno testing and real-world fuel data prove they can recover anywhere from 2 to 6 miles per gallon, depending on the vehicle. These are not gimmick products or gas station fuel additives. These are actual Toyota-engineered components that wear out gradually, and when they do, your engine compensates by burning more fuel. The problem is, nobody tells you about them until something expensive breaks. That changes today. Let's get into it. Fix number 1. Replace the engine air filter element. This is the single most ignored efficiency part on any Toyota. The engine air filter element sits inside the air filter housing box, usually located on the driver's side of the engine bay, connected to the intake hose that feeds the throttle body. Its job is simple. It controls the quality of air entering the combustion chamber. When that filter gets clogged with dust, pollen, and road debris, the engine has to work harder to pull air through it. That restriction changes the air-to-fuel ratio, and the engine control unit compensates by adding more fuel to maintain power. Independent dyno testing on Toyota's 2.5-liter four-cylinder engines shows that a heavily restricted air filter can reduce airflow by up to 15%, which directly translates to a measurable drop in fuel economy. On vehicles like the Camry and RAV4, owners have documented losing between 1 and 3 miles per gallon simply from a dirty filter they forgot about. A quality replacement costs between $8 and $15 and takes less than 2 minutes to swap. No tools required on most models. You open 2 clips on the air filter housing box, pull the old element out, drop the new one in, and close it. Toyota recommends replacement every 15,000 to 30,000 miles, but if you drive in dusty areas or heavy traffic, checking at every oil change is the smarter move. This one fix alone can pay for itself in fuel savings within a single tank. Fix number 2. Replace the spark plugs at the right interval. Toyota spark plugs do not just create ignition, they control how completely and efficiently fuel burns inside the combustion chamber. Over time, the electrode tip on each spark plug wears down, and the gap between the center and ground electrode widens beyond specification. When that gap grows too large, the spark becomes weaker and inconsistent. The result is incomplete combustion, where unburned fuel passes through the engine and exits the exhaust without producing useful power. Dyno data from Toyota's 2 GRFE V6 engine shows that worn spark plugs with excessive gap can reduce combustion efficiency by up to 8%. That loss does not show up as a check engine light or a rough idle in most cases. It shows up as a slow, steady decline in miles per gallon that most owners blame on age or fuel quality. Toyota Iridium spark plugs, which come standard in most models, are rated for 60,000 to 120,000 miles depending on the engine. A set of 4 costs between $12 and $20 for 4-cylinder engines. On V6 engines, a set of 6 costs slightly more, but still falls well under $30 if you buy them direct. The key is matching the correct heat range and gap specification listed in your owner's manual. Installing the wrong plug does not just waste money, it creates misfires that accelerate catalytic converter wear. For 4-cylinder models like the Corolla and Camry, the plugs are accessible right on top of the engine under the ignition coil packs. Replacing them with a basic spark plug socket and ratchet takes about 20 minutes. That small investment restores full combustion efficiency and brings fuel economy back to where Toyota designed it to be. Fix number 3. Clean or replace the mass airflow sensor element. The mass airflow sensor sits between the air filter housing box and the throttle body, usually bolted directly into the intake tube. Its job is to measure the exact volume and density of air entering the engine so the engine control unit can calculate the perfect amount of fuel to inject. When this sensor gets contaminated with oil residue, dust particles, or moisture, it sends inaccurate readings to the computer. The engine control unit then defaults to a richer fuel mixture as a protective measure, which means more fuel is burned per combustion cycle than necessary. Real-world testing on Toyota models with contaminated mass airflow sensors shows fuel economy losses between 2 and 4 miles per gallon, often without triggering a diagnostic trouble code. The sensor can look perfectly fine from the outside, which is why most owners and even some shops miss it entirely. A can of mass airflow sensor cleaner costs between $8 and $12. The process involves removing 2 screws that hold the sensor in place, carefully spraying the delicate sensing element with the cleaner, allowing it to air dry completely, and reinstalling it. Never touch the sensor wire with your fingers or a rag. The element is extremely fragile. Physical contact can destroy it. Cleaning this sensor every 15,000 to 20,000 miles keeps fuel trims accurate and prevents the engine from overfueling. On high-mileage Toyotas, this single step has been shown to restore lost fuel economy almost immediately. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. Fix number 4. Replace the PCV valve. The letters PCV stand for positive crankcase ventilation. The PCV valve is a small spring-loaded component that sits in the valve cover or connects to it through a rubber grommet hose on most Toyota 4-cylinder and V6 engines. Its job is to regulate the flow of crankcase gases back into the intake manifold where they can be burned off instead of building pressure inside the engine. When the PCV valve sticks open, it creates a vacuum leak that leans out the air-fuel mixture and causes rough idle and efficiency loss. When it sticks closed, pressure builds inside the crankcase, forcing oil past seals and contaminating the intake system. Both conditions hurt fuel economy. Toyota engines like the 2AR-FE found in the Camry and RAV4 are especially sensitive to PCV valve condition because their variable valve timing systems depend on stable crankcase pressure to function correctly. A replacement PCV valve costs between $5 and $12 depending on the model. Installation takes less than 5 minutes. You pull the old valve out of the valve cover grommet, push the new one in, and reconnect the hose. Testing is simple. Remove the valve and shake it. If it rattles freely, it still works. If it is silent or feels gummy, it is restricting flow and hurting your mileage. Toyota does not list a specific replacement interval for the PCV valve, which is why most owners never think about it. But technicians who track oil consumption and fuel trim data on high-mileage Toyotas consistently find that a failed PCV valve is one of the most common hidden causes of declining fuel economy. Fix number 5. Replace the oxygen sensor upstream of the catalytic converter. The upstream oxygen sensor, also called the air-fuel ratio sensor, is threaded into the exhaust manifold or the front exhaust pipe directly before the catalytic converter. This sensor reads the oxygen content in the exhaust gases in real time and sends that data to the engine control unit, which uses it to adjust fuel injection on every single combustion cycle. When this sensor ages, its response time slows down. Instead of reacting in milliseconds, it starts lagging, and the engine control unit overcompensates with richer fuel mixtures to avoid lean conditions that could damage the catalytic converter. Fuel trim data from Toyota scan tools shows that a sluggish upstream oxygen sensor can push long-term fuel trims 4 to 8% rich, which directly translates to a 2 to 4 miles per gallon loss on most models. The sensor does not have to completely fail to cause this problem. Gradual degradation is far more common and far more expensive over time because it silently wastes fuel for thousands of miles before any warning light appears. A direct fit replacement upstream oxygen sensor for most Toyota models costs between $12 and $25 from major parts suppliers. Installation requires an oxygen sensor socket and about 15 minutes on models where the sensor is easily accessible from the top of the engine bay. Toyota recommends inspecting oxygen sensors around 60,000 to 90,000 miles, but fuel trim data tells the real story. If your short-term and long-term fuel trims are consistently running positive by more than 5%, the upstream oxygen sensor is the first component to investigate. Fix number 6. Replace the cabin air filter for indirect fuel savings. Most Toyota owners think of the cabin air filter as a comfort part, something that just keeps dust out of the vents. But there is a direct mechanical connection between the cabin air filter and how hard the air conditioning system works, and that directly affects engine load and fuel consumption. The cabin air filter is located behind the glove compartment on most Toyota models. When that filter gets clogged with dirt, leaves, and debris, airflow through the evaporator core drops significantly. The blower motor has to spin faster to push the same amount of air, drawing more electrical load from the alternator. At the same time, the evaporator core cannot exchange heat efficiently, so the air conditioning compressor runs longer and harder to reach the set temperature. That compressor is driven by the engine through the serpentine belt, and when it runs more than necessary, it adds measurable parasitic drag. Testing on Toyota vehicles in warm climates shows that a severely clogged cabin air filter can increase air conditioning-related fuel consumption by up to 3%. On a vehicle averaging 30 miles per gallon, that is nearly a full mile per gallon lost to a $15 filter that takes 60 seconds to replace. Pull the glove box open, squeeze the side tabs, lower it past the stops, slide the old filter out, slide the new one in. Toyota recommends replacement every 15,000 to 25,000 miles, but in dusty areas or areas heavy with pollen, checking it twice a year is the better approach. Fix number 7. Clean the throttle body bore. The throttle body controls how much air enters the engine when you press the accelerator. It is mounted between the intake hose and the intake manifold, and inside it sits a butterfly valve plate that opens and closes with every change in throttle position. Over tens of thousands of miles, carbon deposits, oil vapor residue, and dirt build up around the edges of that butterfly valve and along the bore walls. This buildup restricts AIR flow at idle and low throttle positions, forcing the engine control unit to adjust idle speed and fuel delivery to compensate. Toyota engines with drive-by-wire throttle systems are especially affected because the throttle position sensor expects precise airflow responses that carbon deposits disrupt. The engine may idle rough, hesitate on light acceleration, or simply burn more fuel at cruise speeds to maintain the same power output. A can of throttle body cleaner costs between $6 to $10. The process involves loosening the intake hose clamp on the throttle body, pulling the hose back, spraying cleaner onto the butterfly valve and bore walls while manually opening the valve plate. and wiping away the loosened carbon with a clean microfiber cloth. Do not spray directly into the idle air passages without knowing your model's specific cleaning procedure, because some electronic throttle bodies require an idle relearn procedure after cleaning. On most Toyotas, the relearn happens automatically after a few drive cycles. Cleaning the throttle body every 30,000 miles keeps idle quality sharp and prevents the slow fuel economy loss that comes from a restricted air intake path. Fix number 8. Replace worn or cracked vacuum hoses. Toyota engines rely on a network of small rubber vacuum hoses that connect the intake manifold to components like the brake booster, the PCV system, the evaporative emissions purge valve, and various sensors. These hoses carry engine vacuum, and even a small crack or loose connection creates an unmeasured air leak that the mass airflow sensor cannot account for. The engine control unit sees the oxygen sensor reporting lean exhaust and responds by adding fuel, pushing the mixture rich and killing efficiency. The frustrating part is that small vacuum leaks rarely trigger a check engine light. They sit just below the threshold that sets a diagnostic trouble code, which means the engine quietly overfuels for months or years without any warning. A visual inspection of every vacuum hose during an oil change takes less than 5 minutes. Look for cracks near the connection points, hardened rubber that has lost flexibility, and hoses that feel brittle or swollen. Replacement hoses cost between $2 and $8 each, and most push onto barbed fittings without tools. On Toyota engines like the 1NZFE and 2ZRFE, the most common failure points are the small diameter hoses near the back of the intake manifold and the PCV valve hose at the valve cover. Replacing cracked vacuum hoses restores accurate air metering and brings fuel trims back to where Toyota calibrated them, which means every drop of fuel goes toward making power instead of being wasted. Fix number 9. Replace the thermostat when it sticks partially open. The engine thermostat is a heat-activated valve that sits inside the thermostat housing, typically located where the upper radiator hose connects to the engine block or the cylinder head. Its job is to regulate coolant flow so the engine reaches and maintains its optimal operating temperature, which on most Toyota engines is around 195 to 220 degrees Fahrenheit. When a thermostat fails partially open, coolant flows through the radiator continuously, and the engine never fully warms up. A cold running engine burns significantly more fuel because the engine control unit stays in open-loop fueling mode longer, injecting a richer mixture to protect against cold engine damage. Scan tool data on Toyotas with stuck-open thermostats consistently shows coolant temperatures sitting 15 to 25 degrees below normal, with fuel trims running 3 to 6% rich. That translates to a consistent 1 to 3 miles per gallon loss on every drive, especially during short trips and in cold weather. A replacement thermostat for most Toyota 4-cylinder engines costs between $8 and $15. The job requires draining some coolant, removing 2 or 3 bolts on the thermostat housing, swapping the thermostat and gasket, and refilling. For experienced owners, it is a 30 to 45-minute job. The payback and fuel savings alone makes this one of the highest return fixes on the entire list. If your temperature gauge consistently sits lower than the midpoint during normal driving, a sticking thermostat is almost certainly the cause. Every fix on this list shares one thing in common. They restore systems Toyota already designed to run efficiently. None of them add performance. They recover performance. your engine has been quietly losing. When air metering is accurate, fuel trims stay centered. When combustion is complete, every drop of fuel produces power. When engine temperature is correct, the control unit stops overfueling. When vacuum leaks are sealed, the system breathes exactly as Toyota intended. These are not upgrades. They are maintenance corrections that most owners never make because no warning light told them to. The owners who pay attention to these details are the ones still driving their Toyotas past 300,000 miles with the same fuel economy they had at 50,000. If you're enjoying this video, consider watching this one where I'm sharing more secrets to outlast your Toyota engine.